Okay, so today we're going to talk about heat transfer. We've been spending a lot of time talking about thermal energy and heat in class, so now we need to understand how heat goes from one object to another. There are three methods, and we're going to talk about each of them. So let's get going. So first off, just to remind you guys, heat always moves from a warmer place to a cooler place. Never goes the opposite direction. Always hot to cold, never the opposite. So that means hot objects in a cooler room will cool to room temperature. Basically, you put a hot object in a room, it's going to emit that heat and try to heat up the rest of the room, till eventually they all are equal. Same thing goes for a cold object. You put a cold object in a warm room, it's going to heat up to room temperature. So it's absorbing all of that heat from its surroundings until they're equal. You see this all the time in everyday life. So you put out a glass of cold water. It heats up if you leave it for too long. You put out your soup. You leave it for too long, it gets cold. Same thing. So going off of that, if a cup of coffee and a red popsicle were left on the table in a room, what would happen to them and why? So using what we just talked about, we know that the cup of coffee would cool until it reaches room temperature. It's basically emitting all of that heat to its surroundings. In turn, the popsicle would melt and then the liquid would warm to room temperature. So it's absorbing that heat. Anyone with little siblings would know that. If you leave it out, it's going to melt and make a sticky mess. Okay, so as I said, we have three methods of heat transfer. We have conduction, convection, and radiation. We're going to spend a little bit more time talking about each individually. So we're going to start with conduction. So when you heat a metal strip at one end, the heat travels to the other end. The reason that happens is because as you heat that one end, those particles start to vibrate. And then they vibrate and hit the next ones in line. And then the next ones, and they keep going down, and so on, until the vibrations are passed through the entire strip of metal, and so is the heat. So that is called conduction. So when those particles are in direct contact with each other, they are conducting heat. So I'm just going to restart this little video. So you add the heat at the end, right there, and it's going to start to heat up those particles. They're going to start to move, bounce into the ones around them, and that heat is passed all the way down the end of the strip. Okay? So that would be conduction. Again, those particles start to vibrate, hit into each other, those start to vibrate, and it keeps passing it down, just kind of like dominoes. Okay, so the reason that metals do this is because they're a little bit different from other objects that you might think of. So the outer electrons of metal atoms drift and are free to move. So they kind of are floating around, and this is like a sea of electrons. So when the metal is heated, we're adding energy. Those particles gain kinetic energy, which again is movement. So they start to move more, and this travels throughout the metal. It keeps going and going and going. So those metals have a great method of passing that heat along. They just move through the particles. Those are great conductors. So it's called a conductor when it can pass that heat very easily. Insulators, such as wood and plastic, do not have that same sea of electrons. Their electrons are pretty rigid. They're stuck in place. So they do not conduct the heat as well as metals. So they kind of keep it to themselves. They're not going to change their temperature very easily. So this is why when you have a piece of wood and a piece of metal at the same temperature, the metal feels colder. So metal is a conductor, and it's basically conducting that heat away from your hand. So if you held onto like a metal spoon or something, it would feel cold because it's taking that heat from your hand. Okay? Whereas wood is an insulator. It doesn't really take that heat from your hand, so it feels warmer. So remember, conductors, they take that heat away very easily. Insulators do not. They don't really transfer that heat very well. Next one that we're going to talk about is convection. So what happens to the particles in a liquid or a gas when you heat them? Basically, we should know by now that as you increase temperature, particles start to spread out and they move faster. So when they spread out, that means they become less dense. So when they're less dense, they're going to rise. So this affects fluid movement. So when I say fluid, what do I mean by that? A fluid is a liquid or a gas. So it's something that's capable of that free movement. We know solids can't move, but liquids and gases, they can change shape so they can move. So that's important. Convection occurs in liquids or gases, which we can just call fluids. So, fluid movement is the way that cooler, more dense fluids sink through warmer, less dense fluids. So in effect, that just means that warmer liquids and gases rise up and cooler liquids and gases sink. We should know this. That's why sometimes if you go upstairs in the winter, it's a little bit warmer because that warm air is rising. We have lots of different examples of this that we'll go through. So one would be you're boiling some water. You put that pot of water on your stove, it's touching that stove, and then that's where the heat source is. So it heats that water at the bottom of your pan. That water moves up because it's less dense. It gets away from the heat source, so it cools and it comes back down. So it kind of creates a circle. So if you've ever boiled some water, you know when it starts to kind of bubble up, that's why it's doing that. It's because of these convection currents that we're creating. So convection current, just heat rises, cold sinks. Heat rises, cold sinks. And it keeps going and going in a circle right there. So another example of convection is the reason it's windy at the seaside. If you've ever been to the beach, you know that there's a great breeze that comes. It feels awesome in the summer. So the reason for that is the land is warmer than the sea. So the land is going to be warming that air above it, and it's going to rise. So that air rises up over the land. Now there's almost like an empty space. So that cool air from over the water rushes in. And then that happens again. So the warm air rises, the cool air rushes in, and you feel that nice cool breeze in the summer. Another thing is that cold air sinks. We know this, so it comes in really handy when we have a refrigerator. So if you ever look in your refrigerator, not talking about the freezer, just the part where you have your refrigerator, you like to keep like your water, your fruits, your vegetables. The freezer compartment on that is at the top of the fridge. So the reason for that is that cold air sinks, and as it's sinking down, 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 it's cooling all the food on its way down. Then that warm air, by the time it gets to the bottom, is going to rise up because warm air rises. It's going to be cooled by that freezer compartment again, sink back down, and it creates that, again, convection current. It's really important. Okay, so now we're going to talk about the third method of heat transfer. So, how does heat energy get from the sun to the earth? Well, not through conduction or convection. The reason it can't go through conduction or convection is because there are no particles between the sun and the earth. Conduction, you need those particles to touch. Convection, you need them to move. We don't have any, so it goes through radiation. We're going to do a couple true-false questions right now so that you can get those notes down. These are some really important key points about radiation. So the first one, radiation travels in straight lines. This is actually true. So it travels straight from the sun to the earth. Next one, radiation can travel through a vacuum. Again, that's true. That's really important because there are no particles in space, so it wouldn't be able to travel if it couldn't travel in a vacuum. Radiation requires particles to travel. We know that is false. It's because, again, no particles in space, we wouldn't be getting our heat from the sun if it needed particles to travel. Last one, radiation travels at the speed of light. Yes, that is true. So, while we're talking about radiation, there are a few things that come to mind. Think about absorbing and emitting radiation. So we're going to talk about emission a little bit. Basically what that means is that it can reflect or produce that heat. So in our little experiment, we have 4 containers filled with warm water. We have a shiny metal, dull black, and a shiny black. So what you want to try to answer is which container would have the warmest water after 10 minutes. So again, it already has warm water. Which one is going to keep it the warmest? So the shiny metal container would actually be the warmest after 10 minutes because its shiny surface reflects heat radiation back into the container, so less is lost. So we know shiny things reflect. So when the container has warm water in it, you cover it in shiny metal, it's reflecting that heat right back into your container. That means the dull black container would be the coolest because it is best at absorbing heat radiation. So it's going to kind of take it to itself. It's not going to give it back into the container. It just takes it out for itself. Now we have the opposite. We want to know which one's going to absorb the best. So 4 containers were placed equidistant from a heater. So they're all the same distance. Again, we have the same shiny metal, dull black, shiny black. Now we want to know which is going to have the warmest water after 10 minutes. So this water isn't warm yet. We want to see which one's going to make it the warmest. So that means the dull black container would be the warmest after 10 minutes. And that's because its surface absorbs heat radiation the best. So it's taking in that heat, which then is going to heat up the water inside it. The shiny metal container would be the coolest because it is the poorest at absorbing heat radiation. We know that because it reflects. So if it reflects, it's not absorbing, it's not getting hotter. That heat is going to actually just bounce out. Okay, so those are really important to remember. Dull, dark colors absorb, shiny, bright colors emit or reflect. Okay, so we're kind of getting towards the end, so these are a few review questions. So for convection, why does hot air rise and cold air sink? If you think back to the beginning, we said that is because cool air is more dense than warm air. So it just kind of falls through that warm air. The warm air is going to rise up because those particles are more spread apart and less dense. Next question. Why are boilers placed beneath hot water tanks in people's homes? So you want to get a lot of hot water in your house, so you're going to have your boiler at the bottom of that hot water tank. That is because hot water rises. So if you have it at the bottom, it's going to heat up that water, rise to the top, and then your whole tank is going to be filled with hot water. Now some radiation review questions. So why are houses painted white in hot countries? So if you think about it, a lot of countries like Mexico, Greece, Italy, they have very light colors because they're in hot areas. You don't see very many black houses. That's because white reflects heat radiation and keeps the house cooler. So when you were coming up with ways to keep your houses cooler for your overcycle, one way could have been for it to be white. So this is going to reflect the heat back and keep that house cooler. And the last question is, why are shiny foil blankets wrapped around marathon runners at the end of a race? So if you've ever seen a marathon, when the people are done, they drape them in these shiny foil blankets. If you've ever gone for a run, you might even think about it. At first, when you're done, you're really hot and you're letting out a lot of heat. But then you kind of get cold if you wait too long. I know that happens to me after I go for a run. So basically, the shiny foil blankets reflect that heat that you're giving out right back into you and keeps you from getting cold. So you're giving all this out, that blanket is trying to reflect it, put it back into you so that you're nice and warm still. So that's the end. Again, make sure you have all of your notes filled in. Go back if you need to. And be prepared to ask me some questions tomorrow.